cloud computing case study. And myself, Gayam Naveena, and my teammates are Dominic Irudhayaraj and Gayathri Devi. Introduction: Cloud computing is an on-demand service over a network servers which are hosted on internet to process, store, and organize the data rather than a local server or personal computer. The cloud server services are applicable run on distributed network, which provides a virtual resource for end user. These resources could be accessed by standard internet and networking protocols. Data integrity verification 3 is one of the massive responsibility which cloud data because this probability of involvement in malicious activity of a cloud user and cloud provider is very high. There are many ways to address this problem. Problem analysis. The term data integrity has different aspects such as quality, safety, alternation, and flow of the information between different entities. The most general definition given by and where is the data quality definition, which deals with the expected quality of the data. This means that the data has integrity up to some extent where the accepted quality meets or exceeds. Problem analysis. Kumar and Savina proposed a scheme for data integrity proof in cloud storage. The proposed method selects some bits randomly in data block metadata. The computed metadata is then encrypted and appended to the data item. On the data integrity verification request of client, verification phase is activated by coining a challenge of cloud archive and wait for the response. In this method, multiple hash values are maintained on client side, which increases the computation overheated on client. Proposed solution. The proposed system helps the data owner to verify the integrity of the data stored in the cloud. Data owner can verify whether data is modified by cloud or not. This provides both privacy and integrity to the cloud data. Using proposed system, data owner can also perform dynamic data operations with cloud. This increases the throughput of the system since there are no need download and then upload the data by the data owner when the data files is to be modified or altered. The main task of the TPA is to perform data auditing only to demand by the client. Proposed solution. The TPA compares the newly generated message digest value with the earlier message digest sent by the client. If the both hash values were equal, then it indicates that the data integrity of the file is maintained. If the metadata generated by the TPA and the metadata sent by the client are not equal, then it is interfered that the data has been modified by an attacker. Integrated of the file is not maintained. The results of the data editing or proof verification will be sent to the data owner. Methodology. The data store application consists of the major services: proof recorder, proof manager, and integrity tracker. The first two services are extra layers of integration in the cloud environment and therefore they create extra overhead. The proof recorder adds a computation overhead while collecting provinces from different layers of abstraction of clouds. The proof manager adds overhead because of the provinces management such as storage of provinces. This is the number of subjects, and we store the provinces data in XML object where each individual provinces item costs approximately 1.8 KB of the disk space. These individual provinces that contain information for the client, middleware, and server is present in the cost of the provinces store using the average size of 1.8 KB of the disk space for XML repository. It depicts a negligible cost of the province's storages which remains consistent regardless the size of the original objects.
Data integrity checking in cloud storage solution. In this section, we represent our data integrity checking and tracking scheme for cloud data. As the name illustrated, provenance information as utilized for data integrity proofs and tracking any violations. The existing schemes of data integrity in cloud, such as provable data, proof or returnability, high availability, and using third-party auditors. The proposed schemes uses the provision data, that is the flow of action which are performed on the original data upload to the cloud. This scheme is divided into three major phases: probe recorder, probe manager, and integrity tracker. The probe recorder phase collects various important information related to data items which are created in cloud. The probe manager phase manages the collected information according to the different operations such as deletion, modification, and performed on the data item. The data integrity phase verifies any violation like unauthorized access to the data items. Components of each phases are developed and implemented as services and published to the cloud to serve the end user. The subscription below provide the details of each phases and later components probe recorded. There's a black box architecture of provenance-based data integrity verification diagram. The various component of integrity services, the integrity tracker phase, and then the probability that data can be ported to any platform. In addition, custom algorithm can be designed to port the data into any database. The lightweight we keep only significant preference information. The efficient searching, the customized algorithm can be designed to provide efficient search mechanisms. Methods and techniques. Clouds are designed to be abstracted and various layers of functionality are hidden from the end user. The basic architecture of the services is duplicated in where different layers of abstraction, that is the end user, client application, and the cloud architecture are duplicated. Mm, into the step one in the methods, the step one upload content. The user selected various files of different size and type at client machine and upload them in a cloud storage using data store. The files are uploaded to the cloud with the additional service in action, that is the prover collector and prover manager. The step two method is the modify content. We use a manual approach to modify the information of original data stored in the cloud. We change different metadata like owner name, security permission, location, number of pages amongst it other. The step 3 integrity proof. Lastly, we focused on the integrity proof. Here we used our data integrity service to compare the professor's information with the original data. As soon as we retire the professor's information, the misplaced or missing or changed data was highlighted, displayed. The difference between the original data and the information, that is the integrity proof, using bold and red text. Validation. Provenance is an important and significant information that are used in wide variety of fields for checking quality and establishing trust. The cross-grained scheme is focused on storing a limited amount of significant information, while the fine-grained stream stores a huge amount of data. Both the approaches have their pros and cons. In this work, we utilize the cross-grained schema because we are interested only in the significant information of different item managed to SOA architecture. The conclusion. In this paper, we discuss the importance of the data integrity, especially in cloud computing environment. We analyze some existent technique of data integrity assurance and checking in on-premises as well as in cloud storage. Therefore, we have proposed a new scheme of data integrity proofs in cloud environment to eliminate the such issues and to provide a high flexible solution for cloud users. Using this method, the user may implemented, inserted, deleted, and edit activity over data easily. The presented schema is proved secure in a current security model. That's all. Thank you.